Nice. Yeah. What did you do today?
A bit tired because I come back to Valencia
Okay. Okay. How was your
from
trip?
France.
Yeah. How was your trip?
Well, a rainstorm on the way, but
Oh no.
no problem.
Okay. Um, yeah. Your camping went well then?
Yes, the campsite was good because it's a good campsite. The landscape very well.
Okay. The landscape, very well. The landscape was really good.
Landscape, no, was wonderful.
The wet landscape was wonderful is a good way of saying it too. Um, all right. And Ksenia, welcome to class. How's it going?
Fine, thank you.
Okay. Ksenia, what are you gonna do tomorrow?
Mm, I'll go to the gym and then I'm going to hit the McDonald's.
Okay. At the McDonald's. What do you get at McDonald's?
We have a new offer. It's like some roll with shrimps. So I want to try it.
Cool.
It will be my cheat meal.
All right. Nice. Sounds good. I feel like going to the gym and then going to McDonald's right after is kind of like
It's okay
like
for me.
counterintuitive. But yeah, good. It also depends on what you get. Uh, Catalina, how's it going? Okay. Anna Carolina, what are you gonna do tomorrow?
I have no plans yet. I
Okay.
will watch some. Okay.
No, no, no. Go on. You're gonna watch what? Hmm. All right. Carolina, are you there?
Yes, teacher, sorry, my computer was frozen.
Stupid computer.
Yeah.
Okay.
Teacher, one question. Why you say that a cat nap is a short nap?
A cat nap is just it's a short nap. It's like a quick, yeah, a short
Because
nap.
the cat sleep a lot.
Yeah, I guess so. But cats like don't, I don't know. Cats are like always up and out, and so, like they sleep and they are awake. It's like, yeah, a cat nap is just like a nap in the middle of the day. But
Okay.
yeah,
I
generally
didn't.
they're short.
I
Sorry?
didn't. I don't understand the last one that you taught us.
Which was, do you remember what it was?
Mm, no, but the meaning was
Ah,
really early.
the crack of dawn.
Could you, I
Uh,
don't know how to use it. I've never heard and
so
I.
Okay. So it's like if we're talking about like a negative situation, so like we'd probably say like I think my example was my dog woke me up at the crack of dawn. It's like my dog woke me up so early today, or the screaming children next door woke me up at the crack of dawn. It's like, yeah, it's when you're complaining about having woken up early. Adela woke up at the crack of dawn to go camping. Um, That's not necessarily negative, but it's also not like, yes, I woke up really early. Does that make sense? Yeah. Okay. Right. Well, I think that's everybody. And so we've got two different questions. One, I don't think we'll finish reading about if we read this one, but it's really interesting. Ksenia, can you read this question?
Yes. What would the world be like if the land masses were spread out the same way as now, only rotated by an angle of 90 degrees?
Okay. Good. And the other one, Adela, can you read this question?
Yes, if a meteor made out of diamond and 100 feet in diameter was traveling at the speed of light and hit the Earth, what will happen to it?
Good. Can you repeat diamond?
Diamond.
Earth.
Diamond or diameter? Diameter.
Diamond. Diamond.
Diameter. Diamond and
Earth.
diamond.
And also Earth?
Earth.
Good.
Earth.
All right. And what would you guys prefer reading about? Would your land masses being switched around or the diamond meteor traveling at the speed of light? Any opinions? Nothing?
Mm. Mm.
The
Diamond.
second one? Yes, diamond.
Okay. Right. And Ana Carolina, can you read this part?
Nothing made of matter can go at the speed of light, but that's okay. We can get close enough. No matter how fast you push something, it will never quite get up to light speed. This seems like it can't be right, but it is. Our universe had some wired rules. Weird,
Good.
weird rules. But the closer something gets to the speed of light, the more energy and momentum it has. And this energy and momentum go up without limit.
And the next sentence?
We will start slow and work our way up.
Good. Sounded good. So pretty much we've decided we can't get to the speed of light, but we can get close. Carolina, can you read until visibly?
Okay. Kilometer per second. If we drop the meteor from the edge of space 100 kilometers up, it'll push through the atmosphere without slowing down too much and hit the ground moving about Mach 3 over a kilometer or a second. As it falls, it compresses the air in front of it. When the air is compressed, it heats it up. This is the same thing that heats up spacecraft and meteors. Actual air friction has a little to do with that. By the time it reaches the ground, the lower surface will have heated to over 500 centigrades, which is enough to glow visibility.
Celsius.
Celsius. Oh my god, Celsius.
No worries. It'll.
It'll.
Punch through.
Punch through.
Mach.
Mach.
Kilometer.
Kilometer.
Yeah, kilometer. Compressed.
Compressed.
Meteors.
Which one? Sorry.
Meteors.
Meteors.
Celsius.
Celsius.
Nice.
Celsius.
And Ksenia, can you read this next part until fast?
When it hits the ground, 2 minutes after it was released, it makes a crater 300 meters across, the size of a school, shattering into fragments in the process. 11.
Can you read the comic too?
For scale or something.
Yeah. It's a dinosaur for scale. Anyways, continue.
11 kilometers per second. If we set the diamond in space a little ways away from the Earth and let it fall toward us, it will hit at about 11 kilometers per second. This is Earth's escape velocity, and anything that hits the Earth from space will, thanks to gravity, be going at least that fast.
Okay, anything that hits the Earth from space will, thanks to gravity, be going at least that fast.
And anything that hits the Earth from space will, thanks to gravity, be going at least that fast.
Yeah, we want to have a little bit more rising intonation on will. So from Earth will, thanks to gravity, be going at least that fast.
The Earth from space will, thanks to gravity, be going at least that fast.
Yeah. Anything that hits the Earth from space will, thanks to gravity, be going at least that fast. Good. Really nice job. This is a difficult one. That pause. Can you read until speed? And make sure you read this comic too. Adela?
Sorry. At 11 kilometers per second, the brief descent will be visible as a firewall. The energy of the impact will be comparable to a small atomic bomb, and the crater it will create will be a kilometer across, a little smaller than Meteor Crater in Arizona.
Can you read the comic?
For scale, for Gondor,
And read until speed.
Gondori, for Gondori.
For Gondor! Exclamation point.
Gondor. Sorry, Gondor.
No worries.
Gondor.
And can you read until speed?
72 kilometers per second. This is just about the fastest that anything can hit the Earth if it's orbiting the Sun. The Leonid meteor shower hits at this speed.
Good. Orbiting.
Orbiting.
And kilometers.
Kilometers.
Does anybody understand this comic?
The comic, no, because in the first is the dinosaurs, no?
The first one is the statue of. Oh, so yeah, the first is for scale or something. So like, does anybody know what for scale means?
Scale has a lot of meanings.
Yeah. So what's it mean in this case for scale?
Scale of map.
Yeah. So it's like
for size. Yes.
yeah. So you understand. You understand how big the crater is. Exactly. And have you guys ever seen The Lord of the Rings?
Yes, it's mountain. Gondor.
Yeah, so Gondor is a mythical realm in a place, and this is the statue when you enter Gondor through, this area. And so yeah, we're looking at for scale, which is the Statue of Liberty, and then the statue is saying for Gondor, which it's a joke on saying like for scale. It's a pun using the preposition for. Does everybody kind of understand that? Anyways, it's funny for me. Sorry, guys. Anna Catalina, can you read until bombs?
Until
bombs. Bombs.
Okay. Oddly, the speed that something is going doesn't really affect how deeply it digs into the ground. Isaac Newton came up with a very clever idea for estimating how deeply projectiles
Hmm?
will go in in their targets targets before stopping. It turns out that no matter how fast a projectile is going, if it hits something that's about the same density, it will only go about one body length.
Yeah.
However, it will make quite a splash. The 72 kilometer per second diamond sphere sphere
Sphere.
blast, blasts out a crater over 2 kilometers across, with an energy release comparable to that of the biggest fusion bombs.
Okay, let's look at fusion.
Fusion, fusion,
Yeah. Crater,
crater,
targets,
targets,
estimating.
estimating.
And Isaac. Isaac Newton.
I, Isaac,
Nice. All right, good. And does anybody have any questions here? Okay. So this idea, any projectile will only go about the body length into a target. And Catalina, can you read until ground? Yeah, read until ground.
Okay, here's where things get weird. 3,000 kilometers per second equal 0.01 Celsius?
The speed of light, 0.01 c.
1C. This would be pretty bad. The thing that makes this a little unpredictable is the fact that at speeds in the range of hundreds of kilometers per second, the Earth begins to undergo nuclear fusion. Google that paper tile to find the full text. This combined with a plane or plasma heating may manage to eat apart the diamond sphere completely before it reaches the ground.
Reaches.
Reaches.
Yeah.
And combined.
Good.
Reaches.
Good. Okay. And let's have Ksenia, can you read until kicks in?
But it doesn't do the ground much good. The sphere doesn't spread out enough to make a difference, and it still hits the ground in roughly one spot. The blast releases 1,000 times more energy than the largest nuclear weapon, devastating whatever region it came down over. It gouges out a massive crater, though not the biggest on Earth has ever seen. 0.99 C. This is where relativity kicks in.
Good. Okay. Devastating.
Devastating.
And gouges.
Gouges. And what does it mean, gouges?
It could dig into deeply. So the most common thing that you'll see gouge paired with in the English language is eyes. So somebody gouging out somebody's eyes. It's like digging into and dripping out. The idea of gouging. It's like, yeah, digging a big hole into. Does that make sense? Mm-hmm. Okay. And yeah, it's really commonly paired with eyes. You gouge out eyes a lot. I don't know why. Um, anyways, any other questions? Okay. So when we're going at 0.01 of the speed of light, it's like a fraction of a percentage of the speed of light, really bad things start to happen. And now, if we're at a little bit further close, or a lot closer to the speed of light, Adela, can you read these two paragraphs?
Yes. At this speed, the bonds holding the sphere together are completely irrelevant. It's just a collection of carbon atoms moving so fast that Lorentz contraction flattens the whole thing into a pancake. Although we wouldn't be able to see that visually. The SRIM SRIM particle physics simulation tool can help answer some questions about what happens when it hits. The carbon atoms in the ball carry about 70 GeV volts, I don't know, of energy each. They are actually moving too fast to fuse directly with the air. They just pass through it completely. The air molecules punch 3 meters into the face of the ball before coming to a rest inside it, and it arrives at the ground with a bunch more matter in it than it started with. It also expanded rapidly.
Expanding.
Expanding rapidly.
And molecules.
Molecules.
Yeah. Molecules.
Molecules.
Good. Although. And whole. Sphere. Nice. Okay. And Anna Carolina, can you read the next two paragraphs?
When it hits the surface, it disintegrates completely, jigging downwards and outwards, carving a cone-shaped path down through the bedrock. The impact diff equation no longer applies, since the atoms are literally passing through each other. The energy cracks a hole in the crust and blows open a crater so big you can see the molten mantle. This delivers the energy of 50 dinosaurs, killing
Chicxulub, maybe? I'm not really sure how to pronounce it either.
Okay, Chicxulub impacts, enough to cause a mass extinction, if not change life completely.
Nice. Okay. Depth. Crater. Solid. Good. Okay.
I said crater.
I think it was a little bit off, but yeah, you said it perfectly the second time. Maybe I heard it incorrectly. I don't know. But yeah, it sounded good the second time.
What does molten?
Molten. Okay. Does anybody know what molten is?
Just some sort of liquid after burn. No?
Yeah. So molten. It's like something that's, oh man, molten rock. Let's look at that. This is lava, so something that's molten, it's melted, it's a melted solid. Generally, we're talking about, melted steel or melted rock, something like that would be molten. Any other questions? Okay. And Carolina, can you read here?
I always thought that one of the great things about physics is that you can add more digits out to any number and see what happens, and nobody can stop you. Oh my god, that number is difficult to read.
Yeah.
At this speed, every carbon molecules carries 25 TeV of energy, comparable to particles in the beam of the Large Hadron Collider. A little faster, and we might spot boson in the impact debris.
Okay. Yeah. Let's look at thought. Thought.
Which one? Sorry.
How about
Thought.
thought? Thought.
Thought.
And then we could say comparable. Comparable.
Comparable. Oh my god. Comparable.
Comparable. Yeah. So comparable, you could also say comparable.
Okay. Comparable. Comparable.
Comparable, comparable.
Comparable.
And collider. Oh, hadron. Hadron.
Hadron.
Collider.
Collider.
And Higgs. Boson.
Boson.
Yeah, boson. Higgs boson. Okay. And then debris. Debris.
Debris.
Debris.
Debris.
Debris.
Debris.
Okay.
Debris.
And we're with Ksenia. Ksenia, can you read until this?
Yes. As it stands, the whole thing hits the planet with about the kinetic energy of their orbiting moon. It's enough to punch a gaping hole in the mantle and shake out the surface across the whole planet, turning it molten. This probably ends our life on and around Earth. Oops, cat stepped on my keyboard again and added a bunch more nines.
And yeah, 0.999999, etc. 51c.
It's almost one.
It's almost the speed of light, yeah. Let's have Adela. Can you read this paragraph?
The fastest object with mass in recorded history might be oh my gosh particle, no relation to the good particle, a proton from space that plowed into the atmosphere over Utah in 1991. It was moving at 90.999% of the speed of light, which meant it packed the kinetic energy of a baseball in a single proton. The cascade of particles it blasted apart dwarfed anything the LHC could produce.
Yeah, and the LHC is the Large Hadron Collider. Um, really nice job. Dwarfed.
Dwarfed.
It's got like a war sound in it. Dwarfed.
Dwarf. Dwarf.
Dwarfed.
Dwarf. Dwarfed.
Good. Good. Really nice job. Then maybe cascade.
Sorry.
Cascade. The cascade of particles.
Cascade.
Yeah.
Cascade of
Remember, this is 99 instead of just 90. 99.999% of the speed of light.
99.9999.
Yeah. Good. And plowed into. Does anybody know what plowed into means?
Sorry.
Plowed into. Does anybody know what that means?
Plowed. Plowed. Is
Just dig.
Start in the atmosphere.
I mean, it only has to do with the atmosphere.
I think it's dig into, the same.
What was that?
To dig into. Plowed into is some digged into. No?
I mean, it's like to hit really hard. So if you plow into something, it's like you're running into something really hard. So for like plowing into, we use it in car accidents. Like this car plowed into the building. Generally, yeah, like we say, it's hits something really hard. We use it in car accidents all the time. But if you're talking about winter plows, I mean, you're talking about like something like this that's removing snow. Generally, they move really quickly and then they like hit the snow. Yeah, that's kind of like what it means to plow into something. Does that make sense?
More or less.
Okay, so we use it as a synonym for hit. So, or hit hard. So a proton from space that hit the atmosphere over Utah in 1991.
Or throw the atmosphere or into, no? And
not throw. Throw is a human action. Like you wouldn't say the car threw into the other car.
It's an accident. Yes.
Yeah. So the car plowed into the other car. The proton plowed into the atmosphere. I was looking down at my phone, texting, and I plowed into a stranger in the street. You know, just run into, hit is a good synonym. The Large Hadron Collider is the LHC. Plowed over is like knocked over, Anna Carolina. So plowed over is a little bit different. Same sense of like plowing, moving really quickly, running into something. If you plow it over, it's just like the action of that thing. It falls over. Yeah. And any other questions? Okay. And where are we? Anna Carolina, can you read the next paragraph up until particle?
Yes. Good. Thank you. And nobody knows how it got to be moving so fast. Particles moving that fast hit the Earth a handful of times a year. They seem to come from the general direction of exploding galaxies, but what happened to make them leave in such a hurry, and why they haven't slowed down more before they got here, is something of a mystery. Let's give Aiden's diamond meteor the speed of the oh my god particle.
Good. And slowed.
Slowed.
Maybe Aiden's diamond meteor?
Aiden's diamond meteor?
Yeah, meteor.
Meteor.
Yeah. Meteor. Good. And Carolina, can you read the next paragraphs?
These speeds are so high that my copy of SRIM flatly refused to simulate them. However, we can get some idea for looking at how cosmic rays cascade through rock. The diamond sweeps out a column of atmosphere without seeming to notice and disappears into the crust. A cloud of standing plasma and radiation grows around the entry point as the energy ripples outward through the body of the planet. 40 milliseconds later, the entire far side spans outward in an incandescent cloud.
Yeah, 40 milliseconds later. Can you repeat 40 milliseconds later?
40 milliseconds later. 40 million seconds
Ripples.
later. Ripples? Ripples.
Ripples.
Okay, ripples.
Good, which is kind of like a strange notion. Anyways, any questions here?
Ripples.
Ripples?
Yeah, teacher.
Okay, so when you throw a rock into a pond, ripples will come out. So those are ripples.
Ah, okay. Okay.
Yeah. Any other questions? Flatly? What does it mean to flatly refuse to do something?
Like strong?
Flatly refusing to do something is like completely refusing. It's like you don't even think about it. You just no.
Okay.
So it's a really common adverb to put in front of refuse. You flatly refuse. It would be an intensifier, yeah. It intensifies. It intensifies your refusal, for sure. Any other questions? Okay. And incandescent? Does anybody know what incandescent means?
Yes, there is a kind of light that is um you call incandescent,
Uh-huh.
but it means brilliant, emitting light when it is heated.
Yeah. Yeah. So it's a type of light, light caused by
Mm,
Very,
heat.
very high
in
temperature.
in this case, it means blazing.
Yeah, so it's a light caused by heat, for sure. Blazing, a blazing light. Yeah, good. So like we have incandescent light bulbs and are caused by like this burning of a filament that's been being heated. Okay, and good. Ooh, where are we? That was Carolina. Carolina, you just read, right? Yeah.
Yes, teacher.
And let's have Ksenia. Can you read until space?
Yes. The diamond matter and the cascade of particles it created as it collided with the crust is spread out throughout the body of our planet. The superheated planet glows brighter than the sun. The momentum would be enough to knock the Earth into a different orbit, but the Earth is no more. The energy deposited is 10,000 times greater than the planet's gravitational binding energy, and the planet is blown into an expanding cloud of plasma, with a particularly energetic streamer extending away from the far side of the impact site out into space.
Good. Deposited.
Deposited.
Yeah. Deposited. Okay, yeah. Any questions here? Anybody know what plasma is?
Something that is not a matter. It's different.
Yeah, it is different. It's plasma. Yeah,
I
I
don't
don't
know
know. I
how
don't know how to
to
define it either.
explain. It's also a part of the blood. You call
Also,
the
yeah.
liquid part plasma.
Uh-huh. So if we look, actually, this is a really good
It's a
one.
fluid,
Uh-huh.
same a fluid, no?
Yeah, it's like a fluid. So if we look at this, that's how the molecules are bonded. This is how solid molecules are bonded, liquid molecules are bonded, gas molecules are, and plasma molecules are. So it's like a mix of molecules, excited molecules, particles, free electrons, and ions. If that makes sense to any of you guys, that's what a plasma is. Right. And Vosksenja farther out into space. Hopefully no questions. And where were we? Adela, can you read the next two paragraphs?
The sun cooks and flares as it absorbs a wave of dust. The surface of Mars and Venus are scoured clean by the waves of incredibly high energy plasma. Oh my god. And in the distant future, an alien astronomer on a world hundreds of light years from Earth frowns at a beeping detector and wonders what violent event would make a particle move so fast.
Yeah. Violent. Can you repeat violent?
Violent event would make a particle move so fast.
Scored.
Violent.
Scored clean.
Scored.
Yeah.
Clean.
You
Scored
could
clean.
also say it. I've heard it said scoured. I think scored sounds better.
Scoured.
Yeah, but again, I like scored. I think scored sounds better. Venus. Adela?
Venus.
Venus. Venus.
Venus.
And
Venus.
then hiccups.
Hiccups.
Good. Questions here.
Yes. Hiccups mean.
Yep,
Right?
exactly.
And
Yeah.
flares.
Flares? Does anybody know what a
Flares.
flare is?
Is when the I don't know Firefox, but short to the hand.
Flare. So when a fire flares, it like spits out excessively. So this would be like a solar flare when it like shoots out excessively. When something flares up, that's what a flare is. So this is another solar flare.
And
Okay.
scored.
Scored clean or scoured clean.
Scoured.
Yeah. So if it's like completely cleaned, you're scouring it clean. So you can use like wool, steel wool to scour plates clean. I wonder. Yeah. So.
It's a desert.
Steel wool.
No.
Huh?
No. Sorry. Yes. It's to clean the dish.
Generally, yeah, we're talking about like scouring something that's dirty, like a dish. But if you're scouring clean the face of a planet, you're like eliminating all things that are like not smooth and uniform. Does that make sense?
Yes.
Okay. And any other questions? Okay.
So
It's a very difficult thing to read to understand in English.
Yeah. So
Yeah.
what has happened here? What have we just learned about?
Is more problem when the speed is low. For example, 1 kilometer per second or 10 kilometers per second. When is a high speed, there are a lot of particles don't produce the craters, don't produce these effects. This is only energy. This is protons. So this is, I think, little particles not visible. Every every day, every moment are in the on the air, I think.
Okay. So if we go back to a percentage of the speed of light, things flatten out, like the bonds holding the sphere become irrelevant. So you're right, it becomes atoms, but it's
Uh,
still it's still a ball of energy that's going to be there, just because it flattens out and you can't really see it anymore. The atoms are still carrying a ton of energy, and so what happens is it creates much bigger craters. You know, it goes deeper because the atoms pass other atoms. Yeah.
yes, the C, for example, is the uh, m energy mc square, no? About energy, or no? Or when you use the C for speed.
I can hear you.
No.
The much, much more intense it would be. Adela?
we
Don't hear you.
couldn't
Sorry.
we couldn't hear you, but
Oh
we
no.
heard. No, we heard um with more, much more. Something will be.
Oh man, sorry. Yeah. So the bigger the number, the more intense by long shots it would be. So, this last one would destroy the planet, completely, right? Does that make sense, Adela?
Yes, have a energy about the A E equal mc square, no? The C is about this energy or no?
Yeah. To some extent. So we're talking about.
Is the speed of light? Yes. Uh, the kinetic energy. Okay.
Joshua, we cannot hear you. Can you hear us?
Yes, Carolina. No, Carolina. I
Joshua.
don't. I don't hear
Joshua.
Joshua.
Yes, he cannot hear us.
Bye bye.